providing analog wiring diagrams to you. And it doesn't really make sense to make digital wiring diagrams. So soldering is not possible in the field because it's very, very difficult. The reason for that is that we have some very complex multi-layered boards. And when you've done a soldering, removed component and added a new one, then you have to test the soldering, and that requires special equipment, which you do not have access to in the field. In addition to this, the chance of damage is very high. It's actually much, much more likely that you will damage the board rather than making a successful repair. So instead of talking about analog wiring diagrams, we would like to split the scanner up into blocks. So we look at a block diagram instead. So then you can isolate the defective module or board if you know where a function is taken care of. Then it's possible for you to make a replacement of that defective board in the field. And we would say that this is a more professional take for you. So you can just go to your customer, exchange the part that you need to exchange, make an electrical safety test if needed, and then you're out again and the scanner is up and running. The main source of information for this training is Section 8 in the service manual. The scanner is split into 3 main modules. The first one is the display module. This is the main monitor of the scanner. The second one is the glass UI. This is replacing the keyboard from the older scanners you might know. The third one is the engine module. This is where most of the hardware is located. In this presentation, I'll go through each module and have a look inside which boards we have in the modules, and even dig into some of the boards and see which components do we have on the boards. The display module is where we're displaying the graphical user interface, including the ultrasound image to the user. The display module also includes a set of speakers for audible feedback. The display controller board is converting the HDMI graphics signal from the ComExpress carrier board into LVDS for the 19-inch LCD display. The display controller board further comprises an audio amplifier and circuitry for controlling the display backlight lamp. The backlight lamp is assumed to be LED type, with the LED driving circuit integrated in the panel. The board includes an EEPROM for electrical ID. In addition, the EEPROM stores RGB calibration data for the panel. The hardware monitor function on the SCP card controls backlight and accesses the EEPROM via the DDC interface in the HDMI cable, which is an I2C connection. This interface is not used by the graphic system because this display has fixed settings. The 19-inch LCD panel is displaying the graphical user interface, including the ultrasound image to the user. The 19-inch LCD panel integrates a backlight lamp, which is a white LED. The speakers are reproducing the sound coming from the display controller board. There are 2 speakers units working in stereo. The sensor board is where the orientation sensor of the monitor is located. This sensor is responsible of sensing when the monitor is rotated, allowing the scanner to adjust the monitor content for the new orientation. Why is the monitor and display one spare part assembly? Select the correct answer below. That's right. The 3 main assemblies. The glass UI is one assembly and is where the user can operate the scanner using the touch-friendly graphical user interface. The assembly consists of a control board, which is connected to a speaker, a fan for temperature control, the LCD panel, and the touch control board taking care of the touch functionality. it should not be necessary to calibrate the touch functionality in the field. The assembly is directly connected to the engine through USB and the 12 voltage supply. In addition, the control board has two USB inputs on the left side of the assembly. Calibration of the touch functionality should be a part of the annual preventative maintenance. That's right. This is a view of an ultrasound engine module. It consists of different boards. The main purpose is that it's the brain of the scanner. It's where we create our ultrasound beam and image. It's all the processing power, data storage. It provides all the electrical connectivity to the keyboard, the display, transducer, and external devices. Here we have two different signals. It can either be analog or digital. The front-end beamformer board. Its main purpose is that it's a physical interface to the ultrasound transducers. This is where we're generating our high voltage pulses to excite the transducer ceramics. And it's also where we're doing the amplifying and acquiring the low voltage echoes from the transducers. The SCP board. The main purpose is that it ties the front-end beamformer board and the COM Express carrier board together, allowing the PC backend to control the ultrasound acquisition and receive the ultrasound data. This is where we also do processing of data, and we are buffering data as well. The riser card is a connection between the COM Express carrier board to the SCP card. On this board, we do not do any data processing or any other signal changing processes. This is simply just wiring from one board to another. There are some expansion slots. Currently, we don't use this, but it's for future options. The COM Express carrier board is providing slots for our COM Express module, the GPU card, the Razer card, the keyboard module, the video out, the ATX power supply, the mass storage, USB, LAN, and power button. The COM Express module. This is our PC architecture. It's including CPU, our integrated GPU, so this one is also responsible for displays. System controller hub. Our system memory is a COM standard type 6 module and is also responsible for the video out. The GPU, it's a device that we use for ultrasound image processing. For instance, we have the speckle filtering, we have the compounding as well. It's not used for any digital graphical output. It's only for data processing. For mass storage, we have two hard disks. We have an SSD where we have our Windows 10 embedded on. And then we have a normal hard disk where we have the patient database and the service drive on. The scanner has a built-in power supply. There are two different versions, one for the basic system and one for a battery-driven system. It's medical-graded ATX power supplies, and we also have a front-end power supply. It's powered by the ATX and is generating the high voltage that we need to use on the front-end boards. To allow the PC and the SCP to communicate with the front-end beamformer board, then we have introduced the interconnection board. The board is acting as a bridge between the front-end power supply and the front-end beamformer board, and is only used for communication signals. What is the GPU used for? Select the correct one below and press the check mark in the lower right corner. That's right. Here you can dig deeper into some of the boards. Click on the board you want to learn more about. The front-end beamformer board is providing the physical interface to the ultrasound transducers, generating high voltage pulses to excite the transducer ceramics, and amplifying and acquiring the low voltage echoes from the transducer. We have the probe mux and SPP function. It's connecting the probe elements to electrical channels and providing the 4 physical transducer connectors. The probe mux can be seen not only as a 1 of 4 selector, but more generally as a 192 to 768 mux. It is therefore possible to scan simultaneously on 2 or more connectors. The Smart Probe port, also called SPP, comprises a controller which takes care of visualization of the hardware probe interfaces. This controller communicates directly with the CPU on the COM Express carrier board via the interconnection board. The probe mux and SPP function further provides power switches to apply power to any active probe. Probe power is used for control logic, for motor drivers, and for built-in high-voltage multiplexers. It also provides monitoring of circuits to detect high-voltage leakage to the connector pins. The transmit pulsars are responsible for converting the drive control signals from the transmit beamformer function into high-voltage pulses that excite the transducer arrays, thus generating a sound field in the tissue. The transmit-receive switches are responsible for protecting the sensitive small signal amplifiers in the receive function from the high-voltage signals from the pulsars and for removing the load on the element wires during receive. Transmit beamformer function is supplying the transmitter and the transmit receive function with 192 individual transmit waveforms with individual delays in order to focus the emission in a specific direction and distance. The transmit beamformer function is built as 3 identical 64-channel sections, each consisting of an FPGA and a local memory for TX delay profiles. These profiles are calculated by the CPU on the COM Express carrier board and transferred to the local memory by using the DMA controller in the PCIe switch function on the SCP card. Apart from generating transmit profiles, the transmit beamformer function also controls the high-voltage multiplexers and handles real-time signals to and from the probe connectors in the probe mux and the SPP function. The receive beamformer function is adding the digital channels from the receive function in phase to focus in a specific direction and distance. It can produce several receive beams simultaneously from one emission. The receive beamformer function is further responsible for providing digital data for the analog time gain control function and for reading out digital data from the CV function. The receiver function is amplifying each of the low-voltage outputs caused by the ultrasound echoes from the transducers and converting the analog signals to digital form. The amplification is time variant and is controlled by the ATGC function. This control is common to all channels. The receiver function includes analog filters for optimizing the signals in the frequency range of interest at the input of the AD converters. The receiver function receives its sampling and mixer clocks from the clock generator function. The CV function is summing all CV signals from the receiver function in CV mode. The CV function includes analog circuitry to optimize the signal of interest and 2 AD converters. The ATGC function is converting digital gain control signal from the receive beamformer function into an analog time variant signal that is filtered and forwarded to all channels in the receive function. The clock generator function is generating the fundamental and extremely low jitter clocks for transmit and receive functions. The clocks are distributed on board on the front-end beamformer board as well as to the sequencer subfunction on the SCP card. The I2C function is providing board identification, the ID prom. It's providing cooling fan control and feedback to the hardware monitor function on the SCP card about the actual level of the transmit high voltage rails. This is to make sure that the transmit voltage is actually what it is programmed to be and that the acoustic energy emitted into the tissue is under control. What is ATGC short for? Select the correct answer and use the check mark in the lower. That's right. All sections are finished. You can press the return button. The SCP card implements a number of functions. It ties the front-end beamformer board and the ComExpress carrier board together both physically and electrically, allowing the PC backend to control the ultrasound acquisition and allowing the ultrasound data to enter the PC backend. The RTP function is a real-time control of the data acquisition sequence, both the transmit-receive timing, line mode parameter transfers, and this is the real-time ultrasound data processing. VPP is a data processing for the flow detection modes like color flow mapping, VFI, and spectral Doppler. The acquisition buffer function is that it's storing beamformed ultrasound beams, also called RF data, received from the receive beamformer function through the RTP function. The stored data is then processed by the vector processor. The stored data may also be transferred unprocessed to the USP for alternative processing in real time or post-acquisition. The PCIe switch function has two things it's responsible for. One, it's switching the data traffic between the CPU upstream and the RTP function and the front-end beamformer board downstream. Two, it's providing an efficient multi-channel DMA controller to the system that enables data to be transferred between the system memory and local memories on the SCP card and the front-end beamformer board. The hardware monitor function is responsible for performing different system housekeeping tasks. These tasks include collection of electrical board IDs in the system so that the system software knows the hardware configuration, constantly monitoring temperature sensors on the SCP card and the front-end beamformer board, adjusting system fan speed on the SCP card and on the front-end beamformer board according to the measured temperature, monitoring local supply voltages on the SCP card, functioning as a general I2C bridge to, for example, the FEPS module, controlling or manipulating the system power on and off function, acting as a watchdog timer with ability to shut the system down. The hardware monitor function is powered by a standby voltage, so it is alive as long as the system is connected to mains or a battery. What is not a HWM function? Select the correct answer and press the check mark in the lower right corner. That's right, you selected the correct button to go back to the start. A little about the power distribution in the system. We have two kinds of systems, the basic system and the battery system. So first of all, we will have a look at the basic system. Inside the basic system, the power distribution is taken care of by the ATX power supply. It's an internal power supply which is connected directly to the mains. The ATX power supply is a main power source, and from this ATX we distribute the power to all the boards. So as you can see here, the ATX is powering directly to the GPU card, to the mass storage, to the ComExpress carrier board, which is distributing the power to other boards. Then the ATX is also connected to the front-end beamformer board and to the front-end power supply. For the battery systems, it's almost the same, but there are some changes. In a battery system, the main power supply is located in the battery module, so it's not inside the engine, but it's externally. The ATX power supply is the main power source, and it distributes the power to all the boards just as before. It's possible to have 8 batteries inside the battery compartment, and they are paired in 4 pairs. And you should always have 8 batteries inside the battery compartment. And the engine can basically be powered either by mains or the internal batteries. As you can see here, we have an external compartment now for the mains with a charger module that takes care of charging the batteries, and that can then drive our engine. All the other parts, except for the ATX, are identical. Do the basic system and battery system use the same ATX inside the engine? Select the correct answer below and submit your answer using the check mark in the lower right. That's right page. That's it. Now it's time for a quick quiz. Drag and drop the boards to the left into the correct assembly. Submit your answer using the check mark in the lower right corner. Thank you for listening. In this presentation, I will go through the service configurations which can be done in console mode. When the BK Specto was released, one of the big changes compared to older BK scanners was the glass UI. BK Specto is short for Specialized Touch. Now the main screen content is mainly used for viewing the ultrasound image and measurements. The controls and the workflow has now been moved to a customizable touch interface on the glass UI. The BK Active was later released with the same glass UI as the BK Specto. This is the home content on the glass UI in console mode. The screen has different areas: exam management, transducer and preset, current user, settings, image adjustment buttons, basic monitor buttons, input-output region, and help. Since this is a screen, the content will change depending on what is relevant. For instance, the input-output area is only active if it can be used. Click on Settings to get access to the menu handling all the clinical settings in console mode. To the left, you will see the list of categories which we have divided the settings into. The list is actually longer than what you can see here. Use your finger to roll up and down to see the entire list. Each category might consist of multiple tabs, and a tab can have multiple pages which are indicated by breadcrumbs. There is an input-output area which is activated when it is relevant. In rare occasions, it is necessary to control the mouse. This can be done in the mouse control area. System header is where time and date can be changed. The institution name can be set and used as a DICOM tag. Slide to page 2 of the header where it's possible to import a logo, which will be shown in the top left corner. The Display tab contains application settings related to the display, such as gain unit shown on the screen. Page 2 of the Display tab has more application-related settings. This is where the display brightness of the main monitor can be changed. Auto freeze is a timer function where the user can choose when the system should freeze automatically. The Patient Data tab is where the template for patient information is defined. Each exam type can have a dedicated template. This is a general concept when we talk settings. Many of the settings can be defined for each exam type. In those cases, it will be possible to select the exam type on a list like here. Click on the exam type drop-down button and all available exam types will show on a list. When the exam type is selected, the template can be customized. A dark area means it is a vacant spot. Drag and drop the feature from the input area. White area is a customizable but occupied spot. Drag it from the template and drop it in the output area to remove it from the template. Gray area are default areas and cannot be changed. Also notice there are multiple pages available both in the template and the input-output area. The Localization tab is where language and local settings can be set. The Video Out tab is where the video out is set. Select the video out mode on the drop-down list and select Save. Video out can be off, cloned, or passive. Video out should only be enabled if it's being used. It is essential the external monitors support the resolution for the selected video out mode. The resolutions are defined in the service manual. The next category is presets. This is where the user can get an overview of all the available presets. The presets listed depend on the licenses submitted to the system. In the tab named Available, all exam types and presets are listed. Next to the exam type and presets, a green dot can be seen. This is where the exam type or preset is disabled or enabled. If an exam type or preset is disabled, it will not show up in the clinical workflow, and probes might not be possible to be used. To import, insert a USB flash key and select the drive and the file on the list. To export, insert the USB flash key, select it on the list, and name the file for export. The next category is Measure and Calcs. This is mainly application-related settings regarding calculations and measurements. The Calc List tab is where the Calc List categories are defined. A Calc category is a list of calculations related to a specific exam type. The library of calculations can be used to customize the content in the calculation package. In the Default Calc tab, it is possible to select which calc package is default for all presets assigned to each transducer. The Result tab is application-related settings regarding how the results are presented for each exam type. Notice there are 3 pages in total containing even more application-related parameters. The Preferences tab is one more tab with application-related settings. The OB-GYN category contains 2 tabs, Preferences and Authors. Both tabs are application-related settings for obstetrics and gynecology. The next category is labeling. Just like the calculation packages, there are label packages which can be customized. Select the label package on the drop-down list. Slide between the pages. Select a label and press Remove to delete the label. Empty areas are indicated by a plus sign. Tap on a vacant area and create the label. 2 labels can be linked by dragging them on top of each other. Selecting a linked label and press Unlink to remove the link between the 2 labels. In the Default Labels tab, it is possible to select which label package is default for all presets assigned to each transducer. Similar to the calculation and label packages, there are body mark packages which can be customized. In the Default Body Marks tab, it is possible to select which body mark package is default for all presets assigned to each transducer. In the Bracket tab, it is possible to set up and software calibrate the bracket grid. To create a new grid design, tap on New. Name the grid and select the transducer. Press Next and finish the grid design. It is possible to import and export grid designs using USB flash key. For import, select the import source on the list and select the grid. The next category is Configure Layout. This is where the clinical layout for each exam type is defined. Again, a dark spot with a plus is a vacant area. Each mode has its own design. The exam type is selected in the input area. There are 2 kinds of layouts, Basic and Advanced. Tap on Configure to add buttons. Drag from the input area to a vacant spot. Buttons can be removed by dragging it to the output area. Slide through the pages in the input area to see all options. Also, the basic ultrasound buttons can be changed and reorganized. Here, the mode Elasto is removed and CW is added. In button actions, the user can change mouse speed, brightness, and program buttons for each exam type. This could, for instance, be the probe buttons, the printer button, or foot pedal. Next category is Store and Network. The first tab is Store and Clip. Here the function of the Store button is defined and clip lengths and frame rate can be set. Notice there are settings for both prospective clips and retrospective clips. The next tab is Printer Setup. Image printer is the printer which can be connected to the scanner. Select the printer type on the drop-down menu. Report printer is an office network printer. Use Setup to configure the printer. DICOM Packs is a tab where all the DICOM-related configurations are set up. The system supports Worklist, MPPS, PACS, and DICOM printer. See service documents for guidance to set up DICOM connections. The AE title field is where the AE title of the scanner is defined. All DICOM changes require a reboot for them to be active. Tap on the Status button to see the status of the pending transfers. In the DICOM packs list, all the DICOM connections are listed. Press Add to add a connection, Configure to configure an existing connection, and Delete to delete a connection. Here a worklist is added. Submit the information received from the IT department. The Test button can be used to ensure the setup works. Each DICOM connection has its own setup menu. The PACS menu looks like this. Submit the information about the connection. It's possible to set up more than one PACS. Select which one should be default, if data should be transferred automatically, etc. DICOM Encrypted is an option but requires a certificate to be imported. When the connection is set up, remember to test the connection. In the Wi-Fi tab, it is possible to connect to Wi-Fi networks which are protected. The scanner cannot connect to an open network for security reasons. All available networks will be listed on the list. In the Network Drive tab, it is possible to set up connection to a network drive. Network Drive is an alternative to PACS for external storage, but with less features. Ensure the scanner and the network drive are on the same network. Next category is Security. This is the only category which requires an administrator permission to you. For normal users, the category will be grayed out and inaccessible. The General tab is where admins can force all users to use password for login. Remember, last logged in user when powering on is a key setting for systems where they always use the same user, because then they don't have to select the user when booting the device. Auto logout is a safety feature to make sure an inactive system logs out after a specific time. In user management, the administrator can add, change, and delete users. To add a user, tap on the Add User. Select which user or admin's settings to copy. All columns must be filled out. Use Tab to jump to the next column. And press Next to continue. Submit password and confirm. Tap on Add to add user. Now the user will be visible in the User Manager tab. Select a user and tap on View Profile to see the profile preferences. Here it is possible to add a photo of the user and change the password. The admin can select if the user is an admin or regular user. A regular user does not require to be password controlled, but admins must always be protected by a password. In addition, the admin can select if a regular user is allowed to change profile preferences. The user's preferences are available by tapping on Preferences. All these preferences are user-specific and will only be changed for this specific user. The first tab is named Behavior. The second tab is Measure. Here the user can choose to activate a new measurement when one measurement is completed. The Label tab is where the user can customize the label settings. In Audio Feedback, the user can customize audio settings and volume. In User Preferences and Presets, it is possible to enable and disable exam types and presets for the specific user. All the exam types which are accessible with the current licenses will show up on the list. In the Audit Logs tab, it is possible to set up what actions made on the scanner should be tracked. Enable the different kinds of tracking if relevant. The retention period is used to limit the size of the audit log. Export the audit log to a USB flash key. 3D/4D is an application category. The next category is Service. The General tab consists of 3 columns, one for export, one for import, and one for restore. It is possible to export and import presets, user profiles, system settings, and layout and actions. In addition, it is also possible to export log files by tapping on Logs. Insert a USB flash key and select the drive on the list and press Export. Wait for the files to be transferred. The last column is for Restore. Clear patient data is password protected. The password is the password of the default system administrator. It is important to notice that when patient data has been deleted, it is not possible to recreate it. On page 2, you can enter service mode by tapping on the service mode button. Service mode is protected by the default system administrator's password. Only use Enable Extended Logging if instructed to do so by your BK Medical Technical Support. The License tab is where all submitted licenses are listed. Add new license or multiple licenses using a .lic file. It is possible to view the days left of a demo license and to delete demo licenses. Permanent licenses cannot be deleted in console mode. The Updates tab shows the current software version. The About tab contains information about the scanner, such as serial number, host name. The Updates tab shows the current software version. The About tab contains information about the scanner, such as serial number, host name, IP address, MAC address, free space and hard disk, software build number, and much more. The TP Licenses tab is where we declare all third-party software being used. Partner API is another name of our partner integration that we use to make a digital connection to official partners and accessories like BrainLab and Varian. The configuration is password protected by the default system administrator's password. When the password is accepted, then the configuration menu will show up. You can see TCP IP socket interface is default enabled using 7915. This is our default setting and should rarely be changed. Next to the logo, there is a Help button. Tap on the button and the Help menu shows up. Here the user can watch educational videos and view the user guide for this specific software. Tapping on the user guide will open the user guide on the main screen. The user guide is fully indexed. This makes the search functionality ideal when you want to look up specific subjects. Tapping on the current user will show a list of shortcuts. The user can access the user profile and brightness control. Lock touchscreen is a feature for when cleaning the touchscreen. Log out is to log out manually. Tap on Logout to log out the user. When the user is logged out, then the login screen is shown. This screen lists all the available users and administrators. If a user or administrator is password protected, then the password must be submitted using the built-in keyboard on the Glass UI. This was the end of the service configuration module in console mode. For more This is the certification module.